All right, so now we'll move on to the very last part of our lesson. So that's about the product moment correlation coefficient. So if you recall, we discussed about the product moment correlation coefficient at the beginning of the chapter as well, right? So what is the correlation? Correlation measures the linear relationship, or we can say how well the two variables are explaining each other. So the product moment correlation coefficient, or we say it as PMCC, measures the linear correlation. Now again, very important. Can you see? Linear correlation between two variables. So this product moment correlation coefficient can only check if the two variables have a linear relationship, a straight line relationship. It can't check for any other type of relationship. Okay. The PMCC can take values between 1 and -1, where 1 is perfect positive linear correlation and -1 is perfect negative linear correlation. So guys, we did discuss a little bit about this at the beginning of the chapter. So as you can see here, if now we know we were dealing with scatter diagrams, right, in the entire chapter. So if R is equal to 1, it means your scatter point, the plots are perfectly on a straight line. And if R is equal to 1, you have a perfect positive correlation, which means your graph is has a positive gradient. So when X is increasing, Y is increasing. That's a positive correlation. And R equal 1 means perfect positive, which means all the points are exactly on a line or exactly on a straight line. Okay. So then the other one, if R is equal to -1, we say we have perfect negative correlation. So perfect negative correlation means what? All the points are perfectly on a straight line, but now the difference is you have a negative gradient. So what's happening when X increases, Y decreases. Okay, so all the points, as you can see, are exactly on the line. Okay. And then the other one, so guys, these these are the boundaries. You need to remember them very carefully. You know this. We say the coefficient PMCC as R. Okay, so when I use the letter simple R, it means the PMCC. Okay, so the correlation coefficient. So if the correlation coefficient is equal to 0, what's happening? The points are scattered. I mean, in the sense you don't find any relationship. So no correlation, or there is no relationship. Okay, so it doesn't have to only be 0. It can even be close to 0. So R equals 0 or close to 0. So any R value close to 0. So even if R is equal to 0 0.1, 0 0.2, 0 0.3, do you get it? So any R value that's close to 0, even negative 0 0.1, negative 0 0.2, negative 0 0.3. So you can take a whole range of values. So anything that's close to 0, I mean, will tell us. I mean, it gives us the indication that there is no relationship between X and Y. So these two variables have absolutely nothing to do with each other. Okay. And then guys, these are our normal scatter plots. So you can see here I've given like a few examples. So over here, if the points are lying quite close to a straight line, but it's really close to a straight line, you can see here the points are almost lying on a straight line. So it's like R value probably close to like 0.9, or maybe R equals 0.8. Okay, so this is what we call as a strong positive correlation, because you can see the points are quite close to a straight line. But if you check this other graph I drew here, this one, you can see again the points have a upward movement, but you can see the points are scattered. Compared with this graph, the first one, if you compare this, you can see there's upward movement in both the graphs. But very clearly, you can see that these points are more scattered compared to this, right, guys? So this is more closer to a straight line, while here the points are a little bit more further away from the straight line. So in this case, this guy, in this case, you can see the R value is dropping. So you see the R value is compared to this previous graph, this graph, the R value has to drop, but it's a positive R value because you have a positive gradient. Okay, so that's really important that you are able to understand these things. Okay, the R value compared to this, you can see here there's a drop. Okay, and the other graph I've drawn here, another one. So this is again, you can see here it's a downward trend. When X increases, Y decreases. So it's a downward trend, which means your R value is negative. So it's negative and can be maybe minus 0.9, minus 0.8. So actually you know how to calculate the R value. So this is the equation. Okay, so you can calculate it. The product moment correlation coefficient R is given by R equal Sxy over square root Sxx into Syy. Okay, so at this point, you know how to calculate all of these variables. Okay, Sxy, Sxx, Xyy. You know how to calculate all of them. So you substitute them into this formula and you can get your R value. All right, guys. And then as long, so this is again, after all of these stuff, guys, there's just one last important thing here that you need to know. Okay, so here I have underlined it. As long as the coding is linear. Okay, so in the final step here, they're talking about coding. So guys, we work with coded data, right? So we were working in the previous exercise with the coded regression lines, right? So you know how to convert the coded regression line to the original line. Okay, so we've done the exercises. So now what they're saying is if you are working with coded data, look here, as long as the coding is linear, the product moment correlation coefficient will be unaffected by coding. So guys, this is so important. Okay, this is so important. So as long as your coding is linear, the PMCC value, the R value will not change. Okay, so that's really important. Make sure you mark that. So we'll go to the exercises now. All right, so we'll move on to some questions now to practice with the equation. So question number 1, given that SXX is 92, SYY is 112, and SXY is 100, find the value of the product moment correlation coefficient between X and Y. So guys, they have given you all the three variables. All you have to do is just take those values and just substitute them into this equation, and that's it. So SXY over root SXX into SYY. This is the value of your R or the PMCC. Okay. So SXY value is 100. You divide that by the square root of SXX is 92. Okay, guys. And then SYY is 112. So simply type this in the cal and you can see you get a R value of 0.985. It's a positive R value. And guys, when you see the value 0.985, you need to be able to understand what's going on here. So R value of 0.985 means it's a positive correlation, like it's quite close to 1. So remember what I told you, if the value R value is close to 1 means it's close to a good positive gradient straight line. So there's a strong positive correlation here, right? Can you see? So if this R value is close to -1, it will be a strong negative correlation. If the R value is close to 0, that means there is no relationship. Okay, so the two variables don't have a relationship. So in this case, you can see there is a strong positive correlation. Okay, guys, so which means when X increases, Y increases. Okay. All right, so question number 3. I'll go for the third one. So they say here the ages A years and height H centimeters of 7 members of a team were recorded. The data were summarized as follows. So summation A is 115, summation A square is 1899, SHH and SAH is given. Can you see guys? This is SHH is 571.4. This is SAH is equal to 72.1. Find SAA. Okay, guys. So what do you do here? You have to write the equation for SAA. So it's like SXX. Okay, SAA is sigma A square minus sigma A whole thing square divided by N. So you know how I came up with this equation, right? I am simply using the SXX equation. Instead of X, we use the letter A. Okay. And then sigma A square is 1899 minus sigma A is 115 and you have to square it, divide by N. What's our N value? N is 7 members. Can you see guys? They say there are 7 members. So that means you have 7 points of data. All right guys. So then you can get the SAA value. So SAA is 68 over 7 or in other words 9.714. All right guys. Okay, so this is the SAA value. Okay, and then guys, the other thing is when you are looking at these variables, you need to be able to identify who is the dependent and who is the independent variable. So who is X and who is Y? Or in other words, you recall the word we use is who is the explanatory variable, who is the response variable. So what is it? The ages, A years, and height, H centimeters. So who is X and who is Y? Okay, so you need to understand that the age, A years is your explanatory variable, or in other words, the X variable, the independent variable, and the height, H centimeter, is the response variable or the dependent variable. All right, guys. So the height is what we are measuring with respect to the age. As age changes, we are recording how the height responds to that. Okay. So that's important. Okay. So find the value of the product moment correlation coefficient between A and H. Okay. So you know what you should do here. Right, guys? All you have to do is apply the equation. So instead of x, y, your variables are now A and H. So do the same thing. R equal, the normal equation was Sxy over root Sxx into Syy. So instead of x, we are using the variable A, and instead of y, we are using the variable H. It is substitute. So it's going to be SAH over square root of SAA into SHH. So R equal SAH, guys, that value is given to you 72.1 over square root SAA is 9.714 into SHH is 571.4. All right, guys, so let's get the answer here. The product moment correlation coefficient is 0.9677, right, guys? Is that correct? Or 968 if you correct it to 3 years. Then guys, part C, describe and interpret the correlation between the age and height of these 7 people based on this data. So now you can see it's 2 marks, guys. So you have to give an answer appropriate for 2 marks. Okay, so how is that? Number one, you see, when you consider this answer, we can quite clearly see that your R value 0.968 is what? It's quite close to 1. Do you agree? 0.968 is quite close to 1. So you can see number one, there is a strong positive correlation, right? So there is a strong positive correlation, but that's not enough, guys. If you say strong positive correlation, sometimes you may not get the full mark, because in this case they are giving you a variable. They are giving you variables, so you have to describe the relationship between these two variables also. So what are the two variables? The age and the height. So you have to see what happens to age and what happens to height. Okay, so you have to clearly say that. You know, when there's a strong positive correlation, the points are fitting quite close to a straight line, and it's going, the graph is upward moving, right? So when x is increasing, y is increasing. So then you have to say that. So don't say x is increasing. You have to say, use the correct variable here. So what is it? The age. So you can say as age increases. How do you say as age increases? Or yeah, or else the more older you get, the height increases, right, guys? As age increases, the height also increases. Okay, guys, so this is what it shows according to this data. Okay. All right, guys, so we'll do another question. So I've chosen question number 7. Okay, so they say the following data are to be coded using the coding P equal X and Q equal Y minus 100. Can you see? So we are going to do a question that is entirely, we're going to do this entirely with coding. Okay. So the following data are to be coded using the coding P equal X and Q equal Y minus 100. So the X values are given to you guys and the Y values are given. Okay. So X and Y are the original data points. Okay. So P and Q are the coded data. Complete a table showing the values of P and Q. So how do you get the value of P and Q? They have told P is equal to X and Q is equal to Y minus 100. So guys, shall we prepare the table? So you have to prepare a table. All right. So who is the first X value? So you can see, guys, P is equal to X. Can you see? When they say P is equal to X, it means the P value and X value are equal. So if X is 0, guys, because P and X are equal to each other, P is also 0. Can you all see? So here P is 0, the P value. Okay, so that's the first one. And then the next one, the p-value is 5 because x and p are equal. And the next one, the p-value is 3. All right, guys, I don't need to do anything special here because the x and p values are equal to each other. All I have to do is just write them down. 1. Okay, and then the other guy. Now here, when it comes to q, you have to do some work. Why? Because for q, you have to do y minus 100. So can you see the y value? And the first y value is 100. So you replace the y here. So q equals the y value 100 minus 100 means q is going to become 0. Can you all understand, guys? So the first value is q 0. The next one, q equal y minus 100. The second y value we have is, guys, 117. So 117 minus 100, q is 17. Can you all understand? And the next value is 112, the y value. So substitute 112 here. Q equals 112 minus 100. So that's going to be 12. The next one is 110, the y value. So 110 minus 100, that's going to be 10. Next one, 106. So 106 minus 100 is 6. All right, guys. All right, guys. So you can see I've calculated the summary statistics. Okay. So sigma p square, sigma q square, sigma q, sigma pq. You can calculate this by using the help of your calculator. You can input the data, the x and y. Okay. And you can get this stuff. So I have done this stuff in the previous work, in the previous video. So basically all of you at this point, so it's the end of the lesson, you should be able to get these summary statistics from the calculator. Okay, so you don't need to waste time. You just give one time the input and you can get all of these answers directly. Okay, so this part we have covered. So I'm directly writing them here. Now let's substitute. So sigma p square is 39 minus sigma p is 11 whole thing square divided by n. What's n, guys? We have how many data points? 1, 2, 3, 4, 5. There are 5 data points. Okay, you understand there are 5 data points because there's 5 pairs of x and y. Each x, y counts for 1 pair. Okay, guys. So you can get that value. So what's SPP? All right, guys. So you can see the answer for SPP is 74 over 5, or in other words, 14.8. So SQQ is sigma q square minus sigma q whole thing square over n. So just substitute the values here directly, and you can get the SQQ answer as 164. And then sigma PQ minus sigma Q over n. Sigma PQ is 147 minus sigma P is 11 into sigma Q is 45 over n is 5. All right, guys. So the answer is equal to 48. Okay, so we have all the statistics that we require. So what are we supposed to do? We are supposed to find the values of P and Q to use the values of P and Q to find the product moment correlation coefficient between P and Q. So the product moment correlation coefficient between P and Q R equals SPQ, right, guys? SPQ over square root SPP into SQQ. All right, guys, SPQ is 48 over square root of SPP is gonna be 14.8 into SQQ is gonna be 164. Right, guys? All right, so let's get the value 0.974. So it's a 3SF R value, right? All right, guys. So this is your R value. 0.974. So again, you can see now. Remember, when you write the R value, always check the R value and have an idea in your mind of what's going on. So what's going on here? Here, when the R value is quite close to 1, you remember that your two variables have a strong positive correlation. Okay, so it's really close to 1.974. And they're asking you, okay, guys, now look. Remember now, we did not work with the original data, right? Your original data is XY data. You can see we worked and we got everything for the coded data, right, guys? We got everything for the coded data. So now we got the product moment correlation coefficient also for the coded data. But now look at part 3, they say, hence write down the PMCC, the product moment correlation coefficient between X and Y. Are you looking at it? So previously we found the R value for P and Q, isn't it? We got the R value that is connecting giving the relationship between P and Q. But now in part C, they say hence, guys, you know, when you see the word hence, what does it mean? When you see the word hence, it means use the help of the previous part. Use the help of the previous part and write the PMCC value between X and Y. So what are you going to do? Are you supposed to calculate everything again from the beginning? Get SXX, get SYY and get SXY? Definitely not. Okay, you don't have to do it again. Okay, if you do it again, actually you won't get any marks for this because they're using the word hence, which means use the help of part B. Okay, so for this, I gave you a certain rule. I think if you check back to the note, do you remember this? So when it comes to coding, so we wrote this part down and explained it, right? As long as the coding is linear, the product moment correlation coefficient will be unaffected by coding. Can you see, guys? As long as you use linear coding. What do you mean by linear coding? Linear means where you involve simply just x and just y, not x square, not y square. You know, x to the power 2 is quadratic, not linear, right? Now, do we have linear coding here or do we have other special type of coding? If you look at this, P equal X. Okay, so it's simply a straight line relationship, right? P equal X. There's no X square here. Q equal Y minus 100. There's no Y square here. Do you understand? So these kinds of relationships are what we call as linear. Can you all understand? These are linear coding because it doesn't involve any powers of x and y. So if you have powers of x and y, then they're not linear. So in S1, you only work with linear coding. So then what's the rule? If you are involved with a linear coding, guys, the R value between P and Q is the same as the R value between X and Y. So if you are really want to check it out, you can manually calculate for your own information, for your own growth. If you want to see why they are the same, you can try and see. So you will see that SPQ and SXY, sorry, the R value, this R value is between P and Q, right? So the R value between X and Y is also 0.974. They don't change. It's the exact same answer. This is the part B answer, right? They don't change. The R value is 0.974 between P and Q. The R value is 0.974 between X and Y. You just have to write it. You don't have to do anything. So you just have to write the answer. All right, guys.